4.6 Congruence in right triangles. In this lesson, we are going to prove right triangles congruent using the hypotenuse leg theorem. Now, this is our fifth triangle congruence option, and this one is only used in very special cases when we have a right triangle. And even then, it may not be the one that you need. We'll see very shortly. Now, the first thing we need to do is the definition of a right triangle. Do you know what that is? Definition of a right triangle is a triangle with one right angle. So I bet you knew that. So for this lesson, we need to have some vocabulary. In a right triangle, the side opposite the right angle is called the hypotenuse. So we have our triangle here, and we find the right angle, and the right angle makes a neat little arrow here and points toward the hypotenuse. It's always important to know where your hypotenuse is. Labeling the hypotenuse is one of the main things we are going to be doing, especially in later lessons. The hypotenuse is always the longest side of the triangle, and the other two sides are simply called legs. Now, in this particular lesson, it doesn't matter which leg is which. Later on, we will make a distinction between the two, but not right now. Pardon me. So we have a hypotenuse and two legs in our triangle that has one right angle. Let's take a look at our theorem here. Our theorem is the hypotenuse leg theorem, the HL theorem for hypotenuse leg. And guess which parts of the triangle we're going to use for this one? Yes, that's right, a hypotenuse and a leg. So our requirement here, it says if the hypotenuse and a leg of one right triangle, that's important, are congruent to the hypotenuse and leg of another right triangle, then our triangles are going to be congruent. So what's our requirement here? We have right triangles and the hypotenuse, right? The right angle points at the hypotenuse, and one of the legs. If those are congruent, our triangles are congruent. Very, very simple. And number one, these have to be right triangles. So this is a theorem. We have side, 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 angle, side, and angle, side, angle, which are postulates. And then the two that are different are angle, angle, side, and the hypotenuse leg. Those are the theorems. So 3 postulates and 2 theorems. Now, how do we prove this? You know, because it's a theorem, that it must be proven. So we are given two right triangles and a congruent hypotenuse and congruent legs. A congruent leg, one on each triangle. Now, how do we make this work? Well, we are going to put these triangles together. This triangle comes down and becomes this triangle right over here. Now, take a look here. We've got this leg and this leg are congruent. If we take this triangle and flip it over, flip it around, we take this leg and put it over here. These two legs become one leg, right? They're congruent, so we know the lines are equal, the lines are the same. We can put that there. And what else do we know? we know that the hypotenuses, I think it's hypotenuses, the hypotenuses are also congruent, and we have a right angle. Now, what do you see here? Do you see the isosceles triangle there? I see an isosceles triangle. And if we have an isosceles triangle, what are we allowed to do? We are allowed to mark these two angles congruent. And we know that right angles are always congruent. So we are going to end up with angle, angle, side theorem. Right? Angle, angle, side. Which makes our triangles congruent. So we used the given congruent hypotenuses and the given congruent leg, and the fact that these are isosceles triangles means that we can mark another angle congruent. Again, another very simple theorem. Okay, this right here, lots and lots and lots and lots and lots of stars. These are conditions for the HL theorem. You must meet these conditions to be able to use the HL theorem. Number one, you must have two right triangles. So for this one, we like perpendicular, right? So we can, if we have perpendicular lines, we can say that our angles are right angles by the definition of perpendicular. This is if we are given two perpendicular segments, right? Segment is perpendicular to segment, or line is perpendicular to line. We can make our angles into right angles. And then we can say that our triangles are right triangles by definition of right triangle. Because if our angles are right angles, then we have right triangles. So this is what it's going to look like in your proof. This is one of those multi-step parts. And then we must have congruent hypotenuses and congruent legs. Doesn't matter which leg. So very important here. Let's look at an example of using the HL theorem. Our basketball backboard brackets are shown over here. So we're looking down at the basketball hoop and we see this triangle, and these are our brackets. So the first thing I'm going to do is redraw this. We like to redraw things. And this is point C here, and D, and A, and B. And what are we told? That angle ADC and angle BDC are right angles. So these are right angles. And segment AC is congruent to segment BC. So this is given. Okay. And what do we need here? Reflexive property is going to give us a congruent leg. And right angles, we are given right angles, so we can use that to say that we have right triangles by definition of right triangle. So using the HL theorem, we now have right triangles we can use the HL theorem to prove that our triangles are congruent. All right, go ahead and pause the video, see if you can write up the next proof. Okay, so did you do your define explore? We are given that our two angles here are right angles, and we know that right angles turn into right triangles. And we are also given that these two segments are congruent, and we have labeled those the hypotenuse because they are opposite the right angle. And we know by our reflexive property, I told you we'd use this all the time, that these sides, this side, these sides are congruent, and that gives us a leg. So let's see how we write this into a proof. We have to do three things here. First, we need to make them right triangles. We're told that these angles are right angles. That is given, which means we can say that the triangles, look how I used the same order, that the triangles are right triangles by definition of right triangle. We have a triangle with one right angle, makes it a right triangle. So we have fulfilled that requirement. And then we need congruent hypotenuses, and we are given those. And we need congruent legs. Reflexive property of congruence gives us that one. And then we can prove that our triangles are congruent using the HL theorem. So that was a nice little proof there. And part B says, your friend says you have two right triangles with congruent hypotenuses and one pair of congruent legs. Doesn't matter which leg, the triangles will be congruent. Is your friend correct? Yes. You meet the three requirements. They are right triangles, your hypotenuses are congruent, and the legs are congruent. Remember at the very beginning, 4.1, we said you can rotate, flip, or slide these figures. So as long as you have a hypotenuse and one leg in a right triangle, you're good to go. All right, let's look at an example of a proof. We are told that segment BE bisects, I see bisect already, two congruent something. What's being bisected? It's bisecting segment AD, so two congruent segments. So let's go find BE, segment BE, and who is being bisected? Segment AD is being bisected. So segment BE cuts in half segment AD. So make sure that you are marking the appropriate segment. That's definition of segment bisector. Okay, where we got that. We are also told that, good color for this, segment AB is perpendicular to segment BC, and I immediately think right angle. So let's find segment AB, there it is, and BC, and I mark my right angle, and I'm told that segment DE is perpendicular, so that makes me think right angle. DE is perpendicular to segment EC, so I'm going to mark my right angle, and right angle means either it can be either congruent or it can be either right triangle. We need to figure out which one of these we are using. And we are told that segment AB is congruent to segment DE, so AB and DE, and this is a given. And let's look here at what we have. Well, we could do this both ways. We could do reflexive in the middle here and have angle, angle, side if we, or I mean not reflexive, vertical angle, sorry. We could use vertical angles and make our right angles congruent. if we use our vertical angles here, and then we would have angle, angle, side, or we could go with our new thing that we learned and be one step shorter. Actually, yeah, one step shorter. And if you look here, anytime you see that you have a right triangle, you should check and see, do we have hypotenuse leg? Well, this is the hypotenuse right here. This is the hypotenuse right here. So if we turn them into right triangles, we can use hypotenuse leg. So either way is going to work, but the hypotenuse leg is going to be shorter. So let's take a look at this. We're given that it bisects, right? These are our first two steps here. And this gives us our hypotenuse. That was our hypotenuse. And then we're given the perpendicular, and we are told, so we take our perpendicular, right? We take our perpendicular, and then we turn them into right angles by definition of perpendicular, and then we turn them into right triangles by definition of right triangle. And then so that is going to give us our right triangles. And then we are given this side here. This is our leg. So we have right triangles and a hypotenuse and a leg, and we can use the HL theorem. So there's a couple of ways we could do this. You know how it goes. Thank you, geometry. Multiple ways to do the same problem. All right, go ahead and pause the video and try the last proof. How'd you do on this proof? Let's take a look at it. Let's do our define explore one piece at a time. We were told segment CD is congruent to segment EA. So we find segment CD and EA and we mark them congruent, and that's given to us. And then we are told that segment AD is the perpendicular bisector of segment CE. Soon as you see perpendicular bisector, you see that is two separate things. Perpendicular means right angle. So we're going to deal with that first. So AD is perpendicular to who? CE. So I find AD and CE and I mark my right angles. Now I know perpendicular leads to right angles, leads to either congruent right angles or right triangles. Both of those are options. We have to wait and see which one we're going to use. Do we need to make our angles congruent, or do we need to turn them into right triangles? And then we know, second, that segment AD bisects segment CE. And as soon as we see bisect, we write two congruent, and who does it bisect? It bisects CE. CE, segment CE is being cut in half. So I have two congruent segments. So I find segment CE and I mark them congruent. And that's just by definition of segment bisector. So I look at my triangles here, and I know I have right triangles, so I think, can I use hypotenuse leg? And I look, and I have a hypotenuse and a hypotenuse and a leg and a leg. That means I am going to cross out my congruent right angles here, because I don't need that. I don't have the parts that I need. I only have two sides and an angle, and that doesn't work, and it's not the included angle. So that doesn't work for any of our others. But luckily, right triangles, if I have hypotenuse and leg, I can use the HL theorem. So I see that I have that, so I'm going to break this down. What are our three requirements? We need a right triangle, we need a hypotenuse, and we need a leg, and then we can make our triangles congruent. So the first thing I'm going to do is work on making them right triangles. Now I was told that segment AD is perpendicular to segment CE, right? That was the first half of this here. That's given to me. So I can make these two angles in the middle here right angles, right? I have to turn them into right angles here. And that's by definition a perpendicular. And then once I have right angles, I can turn them into right triangles. These two triangles are right triangles, and that's by definition of right triangle. So now I have right triangles, right? That's one of my first requirements is right triangles. That took me 1, 2, 3 steps to get there. And I had to break my given up to do that because segment AD does two separate things. Segment AD is perpendicular and segment AD is a bisector. Remember, those are two separate things. So I have right triangles. My next requirement is to have congruent hypotenuses. Well, my hypotenuses were given to me, so that one was easy. And now I need congruent legs. Well, this is where the other half of my given comes in. I know that segment AD bisects segment CE. That was just given to me. And that lets me say that segment, oh, I wrote those wrong. Sorry. Used the wrong letters. That lets me write that segment CB is congruent to segment EB, and that's just definition of segment bisector. Okay, so that's how I got my leg. I now have right triangles and congruent hypotenuses and congruent legs, and I can now prove, what was I asked to prove? That my triangles were congruent. Triangle CBD is congruent to triangle EBA, and I used the hypotenuse leg theorem. And so there you go. We are adding more and more steps. You must define and explore and then separate it out into each individual requirement. So we now have 5 possibilities of making triangles congruent: SSS, SAS, ASA postulates, and AAS and HL theorems. And we, last section, added in our isosceles and equilateral triangles to make it so that we can have more congruent parts to make all of this work. Draw, 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 label, 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 and use your colors to help you see it. You're going to have to think about these, but I really believe you can do them. Refer back to these examples that we've been doing, and I think you'll be fine. Enjoy your proofs.